Okay, we're going to continue on with the discriminant with this title, Using the Discriminant. So last time we had a quick explanation as to what the discriminant was, where it came from, and something called the conditions of the discriminant. So remember that the discriminant came from the quadratic formula, and through a wee bit of investigation we discovered that when the discriminant was equal to 0, that means that the roots were real and equal. Okay, so that was in the last video. When the discriminant b squared minus 4ac was greater than 0, then that means that the roots were real. So that just means we definitely get answers. So real and distinct, meaning that they were separate, they were different. Roots were real and distinct. So roots are real and equal. Might look like that. Roots real and distinct might look like that. And then finally, b squared minus 4ac was less than 0, and that meant in turn that we were getting the square root of a negative number, which would then generate what we described as unreal answers. So you wouldn't get real roots, and it might look a bit like that. Okay, so those were the conditions for the discriminant. So what we're going to do next then is we're going to look at some examples with numbers in them. We're going to calculate the discriminant, and then we're going to make a decision as to what does that mean for that particular quadratic, for that particular parabola. So let's just have a think about a difference here between the quadratic formula and the discriminant. So the quadratic formula, what that does is that calculates the roots. But the discriminant doesn't do that. The discriminant tells me whether I've got this scenario, or this scenario. So it tells me whether I've got 2, 1 or 0 answers, the roots being real and equal, 1 answer, 2 answers, the roots are real and distinct, or no answers, the roots are non-real or unreal. Okay, so let's get into some examples, and let's try an example 1. Okay, so example 1. Okay, so question 1, we're going to calculate the discriminant, so we're going to find the discriminant, and we're also going to then in turn state the nature of the roots. Now that's a new phrase. We're going to state the nature of the roots. What does that mean? Well, the nature of the roots are just whether the roots are real and distinct, real and equal, or unreal. So we call these conditions for the discriminant, we call that finding the nature of the roots. Okay, so let's start with an example then. And let's say we start with 3x squared minus 7x plus 2 is equal to 0. So we're going to find the nature of the roots. Now the first thing, similar to the quadratic formula, is we identify A, B and C. So remember that we're thinking about this in its general form, which is ax squared plus bx plus c is equal to 0. So ax squared plus bx plus c equals 0. So we can say that a is equal to 3. We can then see that b is minus 7, not 7, but minus 7. And then finally we can see that c is equal to 2. Okay. So we're then going to calculate the discriminant. What's the discriminant again? Let's just take note of that. That's b squared minus 4ac. So again, substitution. Where I see a, I can replace it with 3. Where I see b, I can replace it with minus 7. And where I see c, I can replace it with 2. So it's b squared, so it's going to be minus 7 squared. Let's put that in a bracket. Minus 4 times a times c, so that's minus 4 times a, which is 3, times c, which is 2. Minus 7 squared is 49. Minus 4 times 3 is 12, and 12 times 2 is 24. And that equals 25. Okay, so d equals 25, that tells us a lot then. What does that mean? That means the discriminant is a positive result. So 25 is greater than 0. Therefore, so those three circles there in a triangle mean therefore. Therefore, the roots are, let's have a wee think about it. What was the note we took before? When d is greater than 0, the discriminant, when that's greater than 0, that meant that the roots were real and distinct, and that was from up here. So d equals 25, 25 is greater than 0, therefore the roots are real and distinct. So we did two things there, and it was the two things we were asked. We first of all found the discriminant, which is 25, and then we stated the nature of the roots, which are that the roots are real and distinct. And how do I know that? Because the discriminant is greater than 0. Okay, so that's the final answer. Let's try an example 2. Okay, example 2. We're going to do the same again. We're going to calculate the discriminant, and we're going to state the nature of the roots for 2x squared minus 3x plus 4 is equal to 0. And remember, we're thinking about this in this form: ax squared plus c, ax squared plus bx plus c is equal to 0. Okay, so a is equal to 2, b is equal to minus 3, and c is equal to 4. A equals 2, b equals minus 3, c equals 4, and it's b squared minus 4ac. B squared, well, b is minus 3, so that's minus 3 squared. Let's wrap that around the bracket. Minus 4 times a times c, minus 4 times a times c, so that's minus 4 times a, which is 2, times c, which is 4. Okay, so minus 3 squared is 9, and then it's minus, let's just take our time, 4 times 2 is 8, and 8 times 4 is 32. Okay, take your time with that. That's going to go into negative numbers then, and we get minus 23. So d equals minus 23. Minus 23 is less than 0. Therefore, the roots are, so just consult your notes at this point. Okay, when the discriminant is greater than 0, the roots are unreal. Okay, so it might be worthwhile at this point just to revisit, what does this mean? Okay, well, non-real roots or unreal roots means that we don't cut the x-axis at all, so it might look like that. In the previous answer for question 1 was the discriminant was equal to 25, and that meant that the roots were real and distinct, which might have looked like that, so two separate roots. Okay, let's try an example 3. We're going to find the discriminant and state the nature of the roots for 2x squared plus x minus 1 equals 0. Okay, so a equals 2, b equals, we want numbers in front of x there. Well, if we can't see the number must be 1. And then finally c equals minus 1. B squared minus 4ac. 1 squared minus 4 times a, which is 2, times c, which is minus 1. Let's just wrap a bracket around that and take our time. 1 squared is 1. Okay, so we get minus 4 times 2 is minus 8. Minus 4 times 2 is minus 8. Minus 8 times minus 1 is plus 8, which equals 9. Okay, d equals 9. 9 is greater than 0, therefore roots are real and distinct. Okay, let's try an example 4. We're going to calculate the discriminant, state the nature of the roots for x squared plus ax plus 16. Okay, so a equals 1, b equals 8, c equals 16. B squared minus 4ac. So that's 8 squared minus 4 times A, which is 1, times C, which is 16. Okay, 8 squared is 64. Minus 4 times 1 is minus 4. Minus 4 times 16, take your time, that's minus 64, and that's 0. Okay, D equals 0. Therefore, roots are real and equal, and we're taking that straight from our notes, from the conditions of discriminant. Okay, let's try an example 5. Minus 5x squared minus 7x minus 4 is equal to 0. Okay, A is minus 5. B is minus 7. C is minus 4. Okay, B squared minus 4AC. So B is minus 7, so it's minus 7 all squared, wrap in a bracket. Minus 4 times A, which is minus 5, times C, which is minus 4. And notice I'm making good use of these brackets when I've got negative numbers to keep everything organised and clear. Okay, square a negative and you get a positive 49. Okay, let's just take our time on this one and work from left to right. It's easy if we take our time. Minus 4 times minus 5. Minus 4 times minus 5 is plus 20. Plus 20 times minus 4 is minus 80. And then take your time here, and 49 take away 80 is minus 31. Okay, so what do we see? We see that the discriminant is negative, so D equals minus 31. Minus 31 is less than 0, therefore, consult your notes again. What does that mean? Roots are unreal.